Good afternoon, good evening, and good morning, ladies and gentlemen. Glad to share you my recent research on streamflow change on the Tibetan Plateau on the different warming level of climate change. I have 4 parts in my talk. First, the background. So we know there are many large rivers originating from the Tibetan Plateau. They provide valuable water resources for a huge number of people living downstream. However, previous studies didn't create a full picture of the climate change impact on the rivers on the different warming level. So the main objective of this study are, first, to evaluate the future change in hydrological regimes with global temperature increasing 1.5, 2, and 3 Celsius degree. Second, to quantify the contribution of rainfall, snowmelt, and glacier melt to the total runoff. Second, data and method. As shown in this table and in this figure, we focus on 7 basins on the Tibetan Plateau, including the south region of the Yellow River, Yangtze River, Mekong River, Salween River, Brahmaputra River, Ganges River, and the Indus River. For the climate impact assessment, we utilized simulations of daily temperature and precipitation from 22 CMIP6 models on the 2 SSP scenarios. Moreover, catchment property dataset were also collected, including DEM, land use and land cover, snow and glacier, as well as soil information. The through model, Tsinghua hydrological model, based on representative elementary watershed approach, was adopted for hydrological simulation. Through model has been successfully applied to many watersheds across China, United States, and Europe. Here, a modified version of through model coupling the modules of snowmelt, glacier melt was adopted. In addition, a new bias correction method, multivariate bias correction algorithm, MBCN, was adopted to correct the GCMs. And we consider 3 warming levels in this study, 1.5, 2, and 3 Celsius degree relative to the pre-industrial period. Okay, the results. As shown in the figure, we found that MBCN bias correction method can substantially reduce biases for precipitation and temperature from GCMs. And these figures show that the calibrated through model is able to capture key features of daily stream flow, snow cover, and glacier dynamics. We found that CMIP6 models reach the targeted warming level of 1.5, 2, and 3 Celsius degree in around 2030, 2050, and 2070 respectively. Annual precipitation is projected to have a slight change at 1.5 and 2 Celsius degree warming level relative to the reference period, and a moderate increase at a 3 Celsius degree warming level. In addition, the seasonal mean precipitation changes greatly among seasons and basins at the different warming levels. Previous projection study show consistent increase in river flows on the Tibetan Plateau on the future climate change. However, our results show the non-monotonic change of river flows for the 7 river basins. The runoff of the study basins, except the Indus, experienced a slight decrease at the warming level of 1.5 Celsius degree. The decreasing trend reverted to increasing at the warming level of 2 and 3 Celsius degree, with large increasing rate about 8.7% to 11.3% in Yellow, Yangtze, Brahmaputra, and Ganges at 3 Celsius degree warming level. So for Indus, the increase at the different warming level between 11.4% and 34% is very striking. The seasonal pattern of runoff remains practically unchanged for all basins. However, the peak streamflow months will change at 3 Celsius degree warming level in Mekong and Salween basins. Runoff components. The rainfall runoff contributes approximately 80 to 90% of total runoff for all basins except Indus. And for Indus, glacier melt runoff contributed to 52% of total runoff. Increased rainfall provided a dominant contribution in Yellow, Yangtze, Brahmaputra, and Ganges at the warming level of 3 Celsius degree, while glacier melt is the main contributor to the changes in Indus. Okay, my conclusion. The non-monotonic response to climate change are found in runoff among basins under different warming levels. That is, streamflow will decrease, although slightly, at 1.5 degree warming level in around 2030, and then increase at 2 and 3 degree warming level upward. This has significant implications for agricultural water resource planning and management. While the projected increase in streamflow at 2 and 3 degree warming level over the Tibetan Plateau bode well for socio-economic development of downstream riparian countries. The projected decreases in freshwater resources in the near term pose severe threat to the growing population and agricultural expansion. So that's all for my presentation. Thank you very much for your kind attention.